In this lecture, we will explore loops in Python, a crucial tool for automating repetitive tasks and efficiently handling sequences of data. We will focus on the for and while loops and also introduce some advanced techniques to enhance your loop usage. Let's start with for loops. The for loop is used to iterate over a sequence like a list, tuple, or string. It's useful when you know the number of iterations ahead of time. Before diving into for loops, let's discuss the range function, which is often used in conjunction with for loops. The range function generates a sequence of numbers. Its most basic form is range stop, where it generates numbers from 0 up to but not including stop. You can also specify a start and a step value, giving you more control. To better understand, let's test it. I'll create a new Python file in VS Code and name it rangeexample.py. In the file, I'll use a for loop to iterate over a sequence of numbers. So I'll say for a variable num being in a range of 5, meaning 0 to 4, I'm setting up a loop to iterate over these numbers. Then on the next line, I'll indent and write print num, which will output the current value of num for each pass through the loop. I'll run this in the terminal using Python rangeexample.py. You'll see each number printed on a new line. Keep in mind the boundary of the range does not include the stop number, so range 5 will go from 0 to 4 and the loop will run 5 times. In each iteration of the loop, the variable num takes on the next value in the range, and then the current value of num is printed. Now let's explore the range function further by adding a start and step value. For a variable x in a range from 2 up to 10, with increments of 2, print x. I'll execute the code. As expected, the loop will print 2, 4, 6, and 8, because the range 2, 10, 2 starts from 2, stops before 10, and increments by 2. Next, let's explore how the for loop can iterate over different types of data. I'll create a new file and name it forloopexample.py. I'll define a list of fruits. Then I'll say for a variable fruit in the list of fruits, print the fruit. I'll run the code from the terminal by typing python forloopexample.py. Here is the printed list of fruits, each in a new line. Sometimes you'll want not just the item in the list, but also its position. You can use enumerate function for this purpose. Let's try it. We'll do two things. First, we'll wrap our list in the enumerate function. Second, we'll add an index variable before our fruit variable. Now that we have access to the position of the fruit, we can print it as well. I'll run this. You'll see both the index and the item printed. This is particularly useful when you need the position of the item in the sequence. Python's for loop is flexible. You can use it to iterate through various data types like lists, dictionaries, and even strings. For example, for each letter in a string like Python, I print the letter. I'll execute it. And we see those letters printed. That's it for for loops. Moving on to while loops. These loops run as long as a condition is true. They are useful when you don't know how many iterations will be needed. Let's create a new file called whileloopexample.py. And add these lines of code. The variable I starts at 1. A while loop continues as long as the condition is true. Each iteration, the loop checks if the variable I is less than or equal to 5. If true, the code block runs. This loop is supposed to print the value of I from 1 to 5. Notice that at the end of the block, the variable I is incremented by 1 to avoid an infinite loop. If I run the code, As you can guess, it prints from 1 to 5. And that wraps up while loops. They are useful for scenarios like reading user input until valid data is provided, or processing data until a certain condition is met. Sometimes you need to nest one loop inside another. This is useful for multidimensional data, like working with grids or matrices. Let's try it by creating a new file and name it nestedloopsexample.py. I'll write the following code. For a variable I in a range of 3, meaning from 0 up to 2, we have a block of code. After an indent inside the block, we have another loop. The internal loop says, for a variable j in a range of 3, we have a block where we print both variables I and j. I'll run the code from the terminal. As expected, the outer loop runs 3 times, and for each iteration, the inner loop runs 3 times, printing all possible pairs of I and j. Looking closer, in the outer loop, I goes 0, 1, and 2. And during each iteration, in the inner loop, j goes 0, 1, and 2, being repeated 3 times. That's it for loops. We've covered for and while loops, how to use the range function, and how to access indexes with the enumerate function. Here's a concise summary of the structure of loops in Python. For loop structure, for a variable in the sequence, we will execute the code inside the block. The loop will repeat for each item in the sequence. While loop structure, while the condition is true, the code block will be executed. The loop continues until the condition becomes false. Nested loop structure. In a nested loop, the outer loop runs first. For each iteration of the outer loop, the inner loop runs completely. We can repeat this process for as many levels of nesting as needed. Loops are an essential tool in programming, allowing you to repeat tasks and automate workflows. With these skills, you can now efficiently handle repetitive tasks and make your programs more dynamic.